Problem 2. A standard production time is 40 minutes. A new operator spent 19 minutes for the first unit and has the learning curve rate is 83%. So that 90 minutes is T1 and 83% is L, as you can see there. And the question is, how many cycles are anticipated before this new operator reach the standard production time? So how many cycles that the question asks for the N capital. So with that, to reach the standard production time, so that 40 minutes is Tn, and the question asks is what is N capital for this problem. And how much production time to reach a cycle time of 40 minutes? How much production time? So it means the sum of all the time from the T1 to Tn. Sum of all the time from 1 to N, what is the production time needed to reach that cycle? And then what is the cumulative average cycle time? So basically the average of the time for the first N unit, the first N units. So let's do one at a time for problem here. The first is we have A, how many cycles are anticipated, and this one, from the problem we have T1 equal to 90 minutes, and we have Tn equal to 40 minutes. From that we have equation Tn, and this problem don't ask any specific approach, so it's better to use logarithmic approach. And in here we have Tn equal to T1 times n power b, as you know. From there we can replace Tn already given, b not given that, so we need to find out b. So b in this case is equal to log L over log 2, and that is log 0.83% over log 2, and that we get negative 0.269. Then we plug in that equation. We have Tn equal to 40 minutes and T1 equal to 90 minutes times n power negative 0.269. So one equation, one unknowns. With your calculator we can be able to find out the n, and that we can do the transformation. So we have that equal to, we can have log both ways. So we have natural log 40 over 90 equal to negative 0.269 log n, and from that we can have log n equal to 3.01. Then calculator we can have that equal to n equal to 20.4. so it approximately 21 cycle. What does that mean? We need 21 cycle to reach the standard production rate of 40 minutes per unit from the initial unit that need 90 minutes, so 21 cycle. And then the B, how much production time to reach a cycle time of 40 minutes? So that go back to the equation that we have, and also in the reference. So that is the new equation that you learn in here. So we have the sum of all the time, Ti, and it from k from 1 to n for any k, right? So let's put it any random k. Then the equation become, and that again it's available in your T1 in your midterm exam reference, mid-semester reference. So here we have it n plus half power b plus 1 minus k minus half power b plus 1 and divide by b plus 1. So that is the total time, production time from unit 1 to unit 21. So from that here in this problem we have applied that t, and in this case k from 1 to 21 and plug in t1 90, and then n plus half, n we have 21, so it will be half 21.5. So we have 21.5. b plus 1, we have b in negative 0.269, so we have 1 minus 0.269 minus k. In this case that is 1 minus half, okay, 1 minus half, so it's here 0.5. b plus 1 minus 0.269, and then of course we go back to b, 0.269 plus 1, so b plus 1 there. So from that equation we get the sum of all the time from here to there, it equal to 1086 hours. What does that mean? To finish the first 21st unit we need 1086 hours. And see, it become easy. What is the cumulative average cycle time? So it means that for on average for the first 20 units, what is the average cycle time? Cycle time, it means one repetition, the time to finish one product. So that one is easy, the average cycle time here. So we have all the time we need for the first 21 unit, divide by n, the number of unit, so it will be 1086 divided by 21, so we have 51.7 hour, which it makes sense. It's somewhere between the 90 hours for the first unit and the 40 minutes for 90 minutes for the first unit and 40 minutes for the 21 units. So the average is somewhere between those two numbers, 51.7 hours, and that we finish problem 2.